Prior to the modern digital computer, that's prior to the 1950s, analog computers were used to solve a number of difficult problems. The analog computer gets its name from the word analog or analogy because real-world problems of any type, could be aerospace, could be flow rates, if these could be put into a mathematical equation, that mathematical equation could be modeled by an electronic circuit. Then the electronic circuit would be run, data collected, and the analogous values would then be translated back into the real-world problem. As long as you can mimic with electronics a real-world equation, even a high-order differential or integral differential equation, you can solve it with an analog computer. Analog computers can be very complicated like the one we just saw, or they can be simpler with this one, which despite its small size could still solve differential equations. In all cases, notice the sets of jacks here. Analog computers were programmed by putting plugs into those jacks to actually build a circuit that would mimic the real live world. Meanwhile, other versions of the analog computer, such as this Polish model, had a screen which allowed it to draw graphs of the problem as it was being modeled or simulated. These analog computers of the early days used amplifiers as one of their main building blocks. Together with capacitors and resistor dividers and things, these amplifiers could be made to perform a number of mathematical operations: addition, subtraction, multiplication, division, integration, differentiation, and with other types of components they could even do log and anti-log operations. As a result, these amplifiers, of which we see a pair here, became known as operational amplifiers, or sometimes were simply referred to as op-amps. Interestingly though, it wasn't just electronics that could do analog computations. Even as recent as the 1990s, the hydraulic automatic transmission has what's called a valve body in it, which is in reality a hydraulic analog computer. It has an input from the driver, such as drive, reverse, neutral, or low gear, but together with two other signals, one called the vacuum modulator signal, which is an oil pressure related to the engine demand as indicated by intake manifold vacuum, and another signal from the governor, which is proportional to road speed. These two hydraulic pressures, together with the input from the driver, directs hydraulic pressures to operate a series of clutches and bands to operate planetary gears to implement a basic three-speed transmission. Another example of a mechanical analog computer was the Norden bomb sight, fame of World War II. Since the late 50s and 60s, the tube-type amplifiers have been replaced by semiconductor amplifiers, and now we see primarily monolithic, one chunk of silicon, which can implement an entire amplifier. These amplifiers can be very tiny, right down here for example, some of them the size of a grain of sand, some of them even microscopic. Others can be fairly large and have the ability to control several amperes of current and several volts, such that they can actually run motors or actuators.